Hello friends, welcome to my channel Physics with Rakshit. In the present video, I will explain some important and fundamental traits of physics which are necessary to study physics. In physics, physicists are always looking for a theory which could unify established universal laws of physics within a framework, and ultimately such theory will reduce number of concepts and number of branches from the framework. That is why unification and reduction are necessary traits of physics. For example, in my previous videos, I have stated various quantum gravity theory which could unify general relativity with quantum field theory. A theory which could unify four fundamental interactions within a framework is said as theory of everything. At present, string theory is proposed theory of everything which could unify gravitational force, strong nuclear force, weak nuclear force and electromagnetic force within a framework. Theory of everything is very important because it could unify four different branches within a framework. It means it will reduce number of branches as well as number of concepts. That is why physicists are looking for a theory of everything since 1960. Another important concept is conservation law. In physics, any physical quantity doesn't change with time. It is said to be conserved physical quantity. In physics, there are four conservation laws. For example, energy conservation law, conservation of linear momentum, conservation of angular momentum and conservation of electric charge. Let us see one by one. According to conservation of energy, total amount of energy in the universe is always constant. Energy neither can be created nor can be destroyed, but it can be converted from one form to another form. There are several applications of conservation of energy in physics as well as various other branches of science. Second conservation law is linear momentum conservation law, which states that if total force that exerts on system is zero, then linear momentum remains constant. Third conservation law is conservation of angular momentum, which states that if total torque that exerts on system is zero, then total angular momentum remains constant. Fourth conservation law is conservation of electric charge, according to which in electrically isolated system, in any kind of process, algebraic sum of electric charge remains constant. So these are four conservation laws which are very useful in almost every branch of physics. Another concept is homogeneity and isotropy of space and time. Let us see what homogeneity and isotropy mean. If any property is same in each and every point in universe, it is said to be homogeneity property. If any property is same in all direction of universe, it is said to be isotropy property. Our space and time both are homogeneous as well as isotropic. Because of homogeneous and isotropic nature of space, we have two conservation laws, that is conservation of linear and angular momentum. Because of homogeneity of time, we have energy conservation law. Because of isotropy of time, we don't know which kind of implications we will have in future. Still, several theoretical physicists proposed several proposals regarding isotropy of time. For instance, Paul Dirac once told that because of isotropy of time, we may have conservation of electric charge. Still, it is a subject of research. So, in the present video, we have seen three important concepts, that is unification and reduction. Second one is conservation laws. Third one is homogeneity and isotropy of space and time.